Good evening all, and let's try the problem which was there in the thumbnail. So the question is 5 square where ABCD belongs to real number. Right, so based on this restriction I need to minimize this summation. But this is very interesting problem because it can be solved very neatly. So as you can see and appreciate, the first expression is nothing but distance of point 42, 0 from a, 1. The reason is I can decode this as root over a minus 42 whole square and plus 1 minus 0 whole square. Similarly, second expression can be decoded as, since we have a and 1 already in the picture, so to connect this path, so this represents a point, let's say 42, 0, and we have another point a, 1. So now we need a, 1 to be connected with this second box. So seeing that motivation, I can write this as a minus b whole square, and we want 1 minus something whole square. And to get 2 square, we need 1 minus 3 whole square. That motivates us because this box give now a, 1 and b, 3. So that motivates us to plug b, 3 from the third box, and we'll have b minus something whole square. So b minus c whole square, and plus we want 3, so 3 minus, either I can write 0 whole square because 3 is already there, or to bring 3 we can bring 3 minus 6 whole square, right? So it's totally up to us how we design. Now here if I'll take b3 and c6, so we can relate here with the next box, and that will demand c minus d whole square plus 6 minus 10 whole square, because we need to create 10, so that's the motivation. Now again we have c6 and d10, and that motivates us to bring d minus 154 whole square plus 10 minus 15 whole square. So the given expression is nothing but sum of all these points. And now if we'll decode it further, so let's see what these points will look like. So clearly I can take point x to be, let's say 42, 0, and we can take point a to be a, 1. We can take point b from next bracket as b, 3. We can take point c as c, 6, point d as d, 10, and last point y as a fixed point 154, 15. So the given problem just boils down to finding the minimum value of the expression xa plus ab plus bc plus cd plus dy. Now what is minimum value of this expression, right? So the minimum possible value of expression, we can see x is a fixed point and a is changing because a will lie on x equal to a and y equal to 1. It's x is changing and y is fixed. So if I'll draw a, 1, so it will be anywhere on this line, right? So let's call this is point a, 1. Similarly, we have a point b over here, which is lying along y equal to 3 line. So next level. Okay. Similarly, we have point c. We have got point d, and then we have fixed point y, which is 54, 15. So roughly, if we'll show this diagram, we have x-axis, y-axis, and we have different lines, right? So y equals 1, y equals 3, 6, 10. So y1, y3, let's say y6 and y10. And given a fixed point 42, 0 is over here, and 54, 15 will be somewhere here. Let's say this is point 1. And all the remaining point is dancing somewhere on these graphs. Okay, so I need to find the minimum path. I need to find the minimum distance between these zigzag path. Of course, minimum distance will be when it is straight line, right? So the answer is the minimum value of this is nothing but simply xy. Coordinate of x is known, coordinate of y is known. Hence the answer for this problem is 42 minus 54 whole square plus 0 minus 15 whole square root. And that distance is going to be just 112 whole square plus 15 whole square. This is 112 square plus 15 square. It comes to a perfect square of 113. And hence the answer for this beautiful problem is 113. So I hope you have enjoyed the problem, and this kind of distance formula creation is very much useful for most of the JEE problems, especially when they give you reflection kind of questions, okay, where this minimization principle is used. Sometimes this minimization principle is used by a reflection. For example, this all of you are familiar. Let's say if you have a given line L equal to 0 and we have 2 points A and B. If P is a variable point on this line, then definitely the minimum value of AP plus PB is going to be AB, and that will be achieved when the point P is located over here. Okay, what will happen if we have 2 points, let's say A and B, on the same side? And now if P is a variable point, clearly for AP plus PB, it's difficult to visualize, but we can play a trick. Imagine if I take the image of B over here. Okay, so B dash. So now PB distance is same as P dash distance. And hence, in order to minimize PA plus PB, I can just minimize PA plus PB dash. And this is same as this question. So here again, we cancel, the minimum distance will be AB dash. So if the point is over here, corresponding to this, I'll get minimum value of AP plus PB. In fact, you can see very clearly these two angles are equal, and it's exactly the path taken by light. So the great nature, if light has an options to travel from A to B, it will take this path following the law of reflection. Okay, so this is a basic proof, and similarly you can find the maximum value by triangle inequality. So all this I have used is sum of two sides AB plus BC is greater than or equal to third side, or difference of two sides AB minus BC will be lesser than third side. So using these two basic funda, this minimization principle, sums can be used coupled with this distance formula. Please stay tuned to my channel and do like and subscribe if you want more quality content for free. Thank you.